Third of our rules, the quotient rule. What the quotient rule allows us to do is to differentiate fractions, or quotients if you like, where we have one function of x as the numerator and one function x as the denominator, and there's the lovely rule. This is how we shall remember it. Square the bottom, write down the bottom, diff the top, minus write down the top, diff the bottom. Let's use this example. So we have x on 1 plus 2x. Now, of course, there are other ways we could do it. We could change that into index form and go x times 1 plus 2x to the negative 1, and then use the product rule. But it's going to be quicker to do this, and this is how we do it, as we say it. It involves a fraction, so I know I've got a vinculum drawn in. That's a fraction bar, remember, a vinculum. So the first thing we do is square the bottom, which simply is the bottom of the fraction, just whack some parentheses around it and go squared. Square the bottom. Then write down the bottom. So now we're moving to the numerator. So we write down the bottom, diff the top, minus, write down the top, diff the bottom. So we've got 1 plus 2x times 1 minus x times 2. And when we tidy all that up, there we go, 1 on 1 plus 2x all squared. So square the bottom, write down the bottom, diff the top, minus write down the top, diff the bottom. When I get something like this, 2x on the square root of x squared minus 4, well, the first thing I do is square the bottom. But when I square a square root, it just becomes power of 1. Write down the bottom. But in this case, the bottom, you'll notice I put it in index form because I know later I'm going to differentiate that, and I'll need it in index form anyway. Write down the bottom, x squared minus 4 to the power of a half. Diff the top, I get 2, minus write down the top, 2x. Diff the bottom, but now I've got to use the chain rule. Bring down the power, lower the power, diff the inside. Tidying that up. Okay, what do we got? We've got some common factors in here. There's a 2, there's x squared minus 4 to the, well, it'll be minus a half is the common factor. But the other thing we notice, minus a half means, hey, I'm on the bottom of the fraction. So I can put that to the other side. I can also tidy up the x squared minus 4 minus x squared, and we end up with minus 8 over x squared minus 4 root x squared minus 4. Now for the fourth rule, a rule that you don't see anywhere. Reciprocal. This can save us time. It's for the specific case, it sort of is the quotient rule, but a really modified one for the specific case where the top of the fraction is a constant number. And when I would do that, it's simply minus the derivative on the function squared. That's all it is. Minus the derivative on the function squared. Okay, sure, I could change this to x to the power of negative 2 and do it that way. But using this as an example of our reciprocal rule. So all I'm going to do is go minus the derivative on the function squared. Well, the derivative of x squared is 2x, so minus the derivative on the function squared, square x squared, I'll get x to the 4. There's my answer, although x will cancel, I've got minus 2 on x cubed. So if I get something like that, minus the derivative on the function squared. Well, in this case, there's a 6 on the top, so I'm going to be multiplying by 6, but the derivative of the denominator in this case is 8x. So when I go minus the derivative, it's minus, the 6 is there of course, 8x on 4x squared plus 3 squared, minus 48x on 4x squared plus 3 squared. So minus the derivative on the function squared. Can save you some time. So there's 2 new rules to play with. 9i.